A lattice point is a point with integer coordinates. For example, 1, 4 is a lattice point, but 3, 2, 4 is not. The line y is equal to 3x minus 5 passes through square PQRS as shown in the diagram. If the coordinates of R are 2009, 2009, then the number of lattice points on the line which are inside the square is. The first thing we need to do is figure out this point and this point. Where does that line first and foremost cross the x-axis right here? And where does it cross QR, the top of that square? If we can figure that out, then we can figure out the number of lattice points because we will have a range. So the first part, which is figuring out where does y equals 3x minus 5 cross the x-axis, is just looking at basically the x-intercept. To figure out the x-intercept, you set y equal to 0. So that means 3x minus 5 is 0. So that means 5 over 3 is x. So x is approximately 1.67. So this is right there, approximately 1.67. Now we have to do the same thing for that. So how do we figure that one out? That point is where y is equal to 3x minus 5 intersects with the line y is equal to 2009. So we set these equal to each other. So 2009 is equal to 3x minus 5, and therefore 3x is equal to 2014, and therefore x, if you calculate this, will be about 671.3. So this point, the x-coordinate, is 671.3. So lattice points are, of course, integers. So all the integers between 1.67 and 671. 2, 3, 4, all the way up until 671. Those are the values for x that will produce integer in terms of our coordinates. But we have to double check and see, is y also going to be an integer? Because the lattice point is such that both the x and y coordinate is an integer. Well, y is equal to 3x minus 5. So the good news is that no matter what you put in for x, no matter what integer value you put in for x, y will also be an integer, right? Because 3x minus 5 will always be an integer if x is an integer. So that's good. So that means all of these are valid. And how many of them are there? Well, that looks like 670 values of x. And therefore, you'll have 670 values of y as well. So the number of lattice points is 670, and therefore number 21, the answer is E. 24 identical 1 by 1 squares form a 4 by 6 rectangle as shown. A lattice point is a point where a horizontal grid line intersects a vertical grid line. A diagonal of this rectangle passes through the 3 lattice points P, Q, and R. When a 30 by 45 rectangle is constructed using identical 1 by 1 squares, how many lattice points will a diagonal of this rectangle pass through? Well, the diagram will be pretty much exactly the same. The only difference is instead of 4 by 6, it'll be 30 by 45. So what we are interested really is an equation of that line that is going to go through all those points. So like any equation of a line, it'll be of the form y equals mx plus b. And what I'll do is sort of call this the x-axis, and we'll call this the y-axis. And we can have this point as the origin. So since the origin is 0, 0, that's a point on the line. Substitute that in, and that immediately gives me that b is 0. So y is of the form mx. Well, we can substitute the point 30, 45. Since it's a 30 by 45 grid, it will basically be 30, instead of 4 by 6, it'll be 30 by 45. So the point at the very end will be 45 for the x-coordinate and 30, like that. So substitute that in, and we get 30 is equal to 45m, and therefore m is equal to 30 over 45, and that means m if you divide top and bottom by 15, is 2 over 3. So our equation of that line is y is equal to 2 over 3x. All right. So now we have to figure out how many lattice points do we have. So if you made a table x, y, and we are going basically from 0 all the way to 45, how many times will we get integer coordinates? Well, 0, 0 is the first one. 45, 30 is the last one. So we know those two for sure. But what about all the ones in between? Using that equation. Well, as you can clearly see, x has to be a multiple of 3. That's the only way that y will be an integer. So when x, for example, is 3, y will be 2. When x is 6, y will be 4, and so on, right? So that's pretty much how it goes. 9, 12, 15, and so on, all the way up until 39, 42, and 45. So now all you have to do is count all those numbers, 0, 3, 6, 9, 12, all the way, ... until 39, 42, 45. And when you do, you will see that there's 16 of them. So number 21, the answer is B. How many points x, y with x and y both integers are on the line with the equation y equals 4x plus 3 and inside the region bounded by x equals 25, x equals 75, y equals 120, y equals 250. So we have a line somewhere, and we've got to basically find integer solutions. So let's draw this like entirely based on the boundaries that they've given me. So we got 25 and 75, so approximately here and here. And this won't be drawn to scale, but 120 and 250. So approximately something like that, where this is 25, this is 75, this is 120, and this is 250. And then now let's plot this y equals 4x plus 3. When x is 25, we're going to have a 103, so approximately here. And when x is 75, we're going to have 303, so somewhere here. And then let's connect those two lines to get an idea of what this will look like, so something like this. So now the equation has to be looked at in terms of these boundaries. So let's just make a little table for ourselves, x and y. And off we go. So they want it inside this region. So we obviously have to go above 25. So let's go to 26. When x is 26, when you plug it into that equation, we get 107. When x is 27, we get 111. When x is 28, we get 115, and so on, right? 29 will give you 119. So far, my x is within that boundary, and my y's are within that boundary. Well, not yet, right? Because 119 is not 120. I got to keep going. 30 gives me 123. Now I can say I am within my boundary for both x and y. And then we just keep going like this, ... And then eventually you can kind of figure out, when will I get beyond that boundary? And you go beyond that boundary when y is above 250, right? 250 or equal to 250. So that basically means that 250 is going to be equal to 4x plus 3. So that means 247 is equal to 4x. So x is equal to 61.75. So that means that once you get above that, you're going to get beyond the boundary. So if it's 62, if we plug it in, it becomes 251, and indeed we are above that boundary. So 61 is 247, and we're still within our range. So that means these values are the ones that are within the range, and we have to just count them up. So it's all the integers from 30 to 61, so that's 61 minus 29, and that is 32. So number 21, the answer is D. In the diagram, two straight lines are to be drawn through 0, 0 so that the lines divide the figure OPQ-RST into three pieces of equal area. The sum of the slopes of the lines will be. So the first line I'm going to draw approximately like this. And the second line, how do I draw that? Do I draw it like here? Do I draw it right through here? Well, it will be drawn like this. And that you know for a fact because we have to start looking at this diagram a little bit more closely. So let's do that. Now, two lines have to be drawn to draw in this diagram to split the area into 3 equal segments. So first we need to figure out what is the area. And we can do that by breaking this up into 2 segments. And if you look at these coordinates, you can quickly realize that this is 6, this is 6, this is 6, and this is 2. So the total area, TA, is equal to 6 times 6 plus 6 times 2, 36 plus 12, which is 48. Now, if those two lines divide it into 3 equal areas, each of those will be 48 divided by 3, which is 16. So that first line has got to be something like this, right? I mean, that may not be perfectly drawn to scale, but something like that. And we can quickly figure out what is this point where it actually crosses that square, because the area is 16, and that is equal to 1/2 base times height. And in our case, the base is from here to here, so I'll just call that going to be my x coordinate. And my y coordinate, which is just top to bottom, well, that's just equal to 6. And if you solve this, you get 32 over 6 is equal to x, and that is equivalent to approximately 5.33. So this xy coordinate right here is 5.33 and 6. So in a very quick way, we can figure out the slope. I'll call that slope m1. m1, if you remember, is rise over run. And the rise is 6, and the run is 5.33. And I know I'm mixing decimals with fractions. You're not supposed to do that, but that's okay. If you put this into a fraction, it's 9 over 8. So I just got the first one, and that's the easier one of the two. Now I got to figure out, where do I draw my other line? Remember, there's got to be 2 lines. Do I draw it exactly like that? Do I draw it like this? How? Well, if you were to draw it exactly like this, does the area equal 16? And you can quickly figure this out. 2 times 12 will be 2 times 6 will be 12, and then 1/2 base times height on this little triangle will give you 1/2 times 2 times 6, which is 6. 6 plus 12 is 18. 18 is greater than 16. So that line cannot be drawn like that. Therefore, we've got to draw a line something like this, approximately. Something like that. And that will allow me to get an area of 16. Okay, so far I hope nothing is complicated, because it shouldn't be in this question. So here we go. So now, of course, I'm going to concentrate on this area right here. And I know that has to equal 16. So 16 is equivalent to 1/2 base times height, which in this triangle, I'm going to have to label some things here. So this little distance from there to there, I'll label that y. Right there, that little distance. And this distance from here to here, that I will label x. Right there. So that'll be x. So going back to my formula, 16 will be 1/2 base times height. Base is 6, but my height is 2 minus y. And then this component right here is the rectangle, which is 2 times 6, minus that small triangle right there. And that's 1/2 base times height, which is xy. So this gives me 6 minus 3y plus 12 minus xy over 2. And then putting everything on one side, we get 18 here. And then minus 16, so we get 2. And then 3y minus xy over 2. And then multiply through by 2, get rid of that fraction. So 6y minus xy is 4. And then I can isolate for y. Y is going to be 4 over, this should be a plus, sorry, 6 plus x. All right, so we got a pretty decent relationship. But obviously we need an actual value for y in order to calculate the second slope. The actual values of x and y. Well, that's where similar triangles comes in. This triangle right here is similar to this triangle right here. Okay, so that basically means that y over 2 minus y is equivalent to x over 6. If you look at these two triangles, this one right here and this one right here, you will see a similar triangle relationship as I have drawn. And this allows me to isolate for one variable. In particular, let's just do x. So it'll be 6y over 2 minus y. And now I can plug that back into here and calculate. So this will become 4 is equal to y times 6 plus x if you cross multiply. Now I'm going to substitute this guy. So it becomes y is 6 plus 6y over 2 minus y is equal to 4. If you expand it, it becomes 6y plus 6y squared over 2 minus y is equal to 4. Multiply through by 2 minus y, and you get 2 minus y times 6y plus 6y squared is equal to 4 times 2 minus y. And continuing, this becomes 12y minus 6y squared plus 6y squared is equal to 8 minus 4y. Good news is those two cancel, and then this just becomes 8 is equal to 16y, and therefore y is equal to a half. And that's it. Y equals to a half. That allows me to figure out the slope of this guy right here, which is this line right here, M2. M2 will be, again, I can do it here. M2, again, rise over run. And this time, our rise and run is as follows. The rise, I'm actually now looking at this triangle, that situation for rise over run. My rise is from here to here, which is the equivalent of 2 minus y. And my run is 6. So 2 minus y, well, y we just figured out was a half. So this is going to be 2 minus a half over 6. And that's 3 over 2 over 6, like this. And therefore, this is going to be 3 over 2, 1 times 1, 6, 1/4. And there we can have it. We've got M2 equal to a quarter, M1 equal to 9 over 8. And they want the sum of those. So 9 over 8 plus 1 over 4. If you add them up, it's 11 over 8. So number 22, the answer is E. Suppose that k is greater than 0 and that the line with the equation y is equal to 3x k plus 4k squared intersects the parabola with the equation y equals x squared at points P and Q as shown. If O is the origin and the area of triangle OPQ is 80, then the slope of the line is. Our line here is y is equal to 3k times x plus 4k squared. And since all lines are of the form y equals mx plus b, where m is the slope is 3k. So essentially the question is asking me to find what is the value of 3k. If I do that, I'll be done with the question. So these two graphs, this one and y equals x squared, intersect at 2 points, and those 2 points are P and Q. So let's set them equal to each other. So we have 3kx plus 4k squared, like that. And let's put everything on one side, and see what we get. We get a quadratic equation. So we can use the quadratic formula to see what kind of values we get for x. So x will be equal to minus b plus or minus the square root of b squared minus 4ac, and then all over 2a. So that's going to give me 3k plus or minus. That looks like 9k squared plus 16k squared. So 9k squared plus 16k squared all over 2. And therefore x looks like 3k plus or minus the root of 25k squared, which is 5k all over 2. And when you do this math, it looks like 4k or minus k. So I'm assuming that this guy here is 4k and this is minus k. So what I'm going to do is blow that up a little bit. So let's put it down, these values. Let's graph them. So this guy here is 4k, and this is minus k, like that. And now we can proceed with the next part of the question, which is trying to figure out what is the actual numerical value of k. And we use the clue that this triangle has an area of 80. So what I'm going to do is compare the entire triangle and then subtract from it these triangles, and that should help me figure out an equation that solves for the numerical value of k. Now the first thing I think I will need, though, is I'm going to need that point. So when does this line cross the x-axis? Well, that line was 3kx plus 4k squared, and we want to know when does that equal 0. Well, let's see here. Let's put everything on one side. So 3kx is equal to minus 4k squared. 1k cancels, so 3x is equal to minus 4k. Therefore, x is equal to minus 4k over 3. So this point right here is minus 4k over 3. Okay, I think I have everything I need to look at the area now. The area is 80 of that shaded region, and that is equivalent to the full triangle. Subtract from it these two triangles, that one and this one. So the full triangle, 1/2 base times height. The base is from there to there. So that's 4k minus 4k over 3, so plus 4k over 3. That's going to be the base. The height is from here to here. And we need to, of course, label the heights. Since it's on the parabola y is equal to x squared, this point right here, Q, that point right there, is going to be 4k, and then 4k squared, so 16k squared. And then this point P is also on the parabola, so that point right here is going to be minus k, and then minus k squared, which is k squared. So going back to our 1/2 base times height, this was the base, and this is the height, and the height is the y coordinate, so 16k squared. From that, I have to subtract this triangle and this triangle. Okay, so this triangle, that should be pretty straightforward. 1/2 base times height. This is the base, which is 4k over 3. And the height is this, which would be the y coordinate right there, which is k squared. And then I have to subtract this triangle. And that one, 1/2 base times height. The base is easy, that's 4k. And then the height is the y coordinate of that point right there, so 16k squared. Okay, so this is the equation I have to solve to figure out the numerical value for k. All right, so let's get rid of some fractions. Let's multiply through by 2. And then once I do that, let's add some of these fractions. So 4k plus 4k over 3, that's going to be 16k over 3. And then I've got to multiply that by 16k squared. This is 4k to the power 3 over 3. And then this is 64k to the power of 3. Okay, I think I can... This is going to be 256k to the power of 3. And let's just multiply it through by 3 to get rid of the fractions. Minus 4k minus 64k. Okay, so that's going to be 256 minus 4 minus 64. Or I had to multiply, sorry, I had to multiply the 64 by 3 also. Forgot to do that. 192k squared. Okay, so 256 minus 4 minus 192, that looks like 60k to the power of 3. And on this side, we've got 3 times 160. So 3 times 160 is 480. 480 divided by 60 is 8. So 8 is k to the power of 3. Therefore, k is 2. Great. And at the very end, we had to figure out, if you recall, the slope of that line, which is 3k. I even wrote it over here. Well, k is 2, so 3k would be 3 times 2, which is 6. So number 22, the answer is D.